So I'm creating this video to help you with some problems you had with the review exercise part 1. So I'm just going to go through the questions that people left blank from those that submitted their work. If there are others you want help with, then you should be asking in the chat or emailing me. You should be proactive. Okay, so without further ado, let's have a look at what people struggled with. So question 1, so they didn't struggle with parts A, B or C, but we'll go to explain briefly so we can explain part D. So we've got researcher is hired by a cleaning company to serve the opinions of pension scheme. We've got 55 managers, 495 cleaners. A census. A census is when you ask every single person that it affects, so that would be asking all 550 of them. And says one disadvantage of this in context, so it's very time consuming and it's going to be potentially expensive if people are paid per hour and you're taking up everyone's time for it. And to collect the data, you ask the first 50 that leave, and so this is opportunity sampling. It's when you just opportunistically choose who to ask by whoever's in front of you, and give 2 reasons why it's biased. Well, if everyone's on the same shift, if everyone's leaving at the same time, if people are leaving in groups of friends, then they're going to likely share the same views. Okay, perhaps you at 5 o'clock a lot of the employees leave and you just get employee opinions. Perhaps you ask later on and that's when the manager's leaving and you get manager opinions only, and it's going to be biased either way. So on to part D. So explain briefly how the researcher could select a sample of 50 employees using a systematic sample and a stratified sample. So systematic is when you ask every so often. So if there was everyone in a line, you would just figure out, well, how many people do I need to ask? 50, so let's divide the line into groups of 50 and ask every 11th person. If we want to be particularly accurate, we should say that within the first 11 you should randomly pick somebody to start from, because otherwise if everyone is lined up alphabetically or age order or whatever order you start with them in randomly, then the first person is always going to get picked in one of these unless you randomize the first group, and the last person is never going to get picked unless you randomize within these groups. And then a stratified sample. So if we remember that there was 495 cleaners and 55 managers, the stratified sample would appropriately ask the right number of each of them. So we want 50 people, so that's 1 in every 11 people. So 55 divided by 11 means, well, let's ask 5 managers and 45 cleaners, and then everyone gets a representative say in the pension scheme. So let's have a look at what the answers say. So label the employees 1 to 550, obtain an ordered list, select the first person using random numbers, and then every 11th person. Yep, that's pretty much what we said. And then label the managers, label the cleaners. We want 5 managers, 45 cleaners. Yes, that's what we said. Okay, next one people struggled with was question 7. This was left blank. So an ornithologist is collecting data on the lengths in centimetres of snowy owls. She displays the information in the histogram shown below. So we've given the information that there are 26 owls in the 65 to 67 group. There's no scale on the frequency density, but we know that area represents frequency. So we know that this block here, which is, if you counted the squares, is 52 squares, is represented by 26 owls. So that means that 1 owl for every 2 squares. Then if we want to figure out the probability ones between 63 and 73, if we have a look at 63, that's going to be, so 2, 4, it's going to be from here to 73 is going to be all the way to 1, 2, 3 to here. If we figure out how many squares, we can figure out how many owls that would be out of however many there are in total. So this is 26 owls. We can similarly work out how many, so there's going to be another, so it's 2 owls per square, so there's another 8 squares there, so it's going to be another 16 owls, etc, etc, etc. You figure out how many owls there are in that block we're interested in, how many owls there are in total, and divide them, and that'll give you your probability. And if you do that, you should get 0.82. So now you know how to do it. You can give it a go and check that you get that. Also, these arrows pointing you to certain sections, they go back in the book and they explain how to do some of these things. So if you're stuck, that might be your first thing to have a look at. Next question we've got is the daily maximum temperature is recorded at Heathrow during May 2015. We've got to use linear interpolation to find an estimate between 20 to 80% range. Right, it's telling us 4.9, and these words, linear interpolation, might seem a little bit strange. This is because it's not really tested in the WJC book. It doesn't say explicitly it won't be tested, but it's not mentioned anywhere, and therefore we can safely assume that it won't be tested. So we don't really need to worry about this, but I'll explain how to do this anyway, just so that for the people that want to understand. So you've just got to realize that we can assume that 20% of the way through, if there's 30 people in total, there's actually 31 people. So if there's 31 people in total, then 10% will be 3.1 people in, 20% will be 6.2 people in. You have a look and figure out roughly where they are. The same thing where the 80th percentile person is, and then figure out roughly what fraction of the way through the group they'd be if they were evenly spread out, and subtract those to get your interpercentile range. It's much easier to do on a cumulative frequency graph. So 80%, so the cumulative frequency graph goes up to 31, 80% will be up at about 25. If we go across there, that's 20, and 20% is going to be at about 6, 7, it's going to be about 15, so 15, 20, it's going to be about 5, so we're going to get a very similar result. And it's one of the questions people are stuck with is use your graph to figure that out. So you go across at 80%, you go across at 20%, you go down, you read off the values and subtract them. Now, which estimate is going to be more accurate? Well, the linear interpolation is going to be more accurate, because with your graph, you're drawing these curves by hand, and when you go across, your curve might be in a slightly different position to somebody else's, and therefore it's a little bit less accurate, but it does the same thing. Then it says estimate the maximum number of days in May 2015 where the daily maximum temperature in Heathrow is greater than 15. Let's look back at our graph. 15 degrees, you go up, you reach about 5, and so there's going to be the other 25 days are going to be above this, because there's just 5 days that are below 15 degrees, so 25. Let's check our answers. Interpolation is going to be more accurate, and 25 days. Yeah, we're happy with that. Right, then next we've got question 9. So we've got a manufacturer stores drums of chemicals. During storage, evaporation takes place. A random sample of 10 drums was taken. We've got X weeks, and the evaporation lost in milliliters, Y milliliters. We've got a graph. Draw the scatter graph. That wasn't the problem, that's easy enough to draw. Give a reason to support fitting the regression model of y equals ax plus a plus bx to these data. Well, it's because this is your equation of a straight line, and if we look at our graph, all those points roughly fit in a straight line. If they were all over the place or they formed a curve, it would not be suitable, but because it fits a straight line, it is suitable. They lie close to a straight line. Yes, got that. So next one, we've got a table showing average monthly temperature and the number of ice cream sold in hundreds in a Riverside snack barge. Okay, and we've got our table of results. So we've got the temperature and how many hundred ice creams they sold. So following data were figured out. We've got a mean of 15.3 and a standard deviation of 10.2. An outlier is observed at plus or minus 2 standard deviations from the mean. So if you add on 2 lots of 10.2, 45 is going to be an outlier. So add that on. Yep, that's an outlier. Why is it? Give a reason whether it should be omitted or not. Well, it's very, very high. If you've got other days surrounding it of 10 and 14 degrees, that seems like a mistake. Somebody wrote it down wrong. Perhaps it's 4.5, perhaps it's 15, who knows. So it seems like it should be excluded. This value is omitted from the data, and the equation of regression line of C on T is calculated as this. Give an interpretation of 2.81 in this regression line. So we've got our regression line, and this, we're going to remember, is hundreds of ice creams, temperature. So this means that for every extra 1 degree in temperature, there's going to be 281 extra ice cream sold. That's what that number means. It's the gradient, but an interpretation means we've got to relate it to the context of the question. State with a reason using your regression line to estimate the number of ice creams sold when the average monthly temperature is 2 degrees would not be appropriate. Well, let's look back at our data. Well, the lowest temperature was 5 degrees, and we should not just take things outside of the range. We shouldn't extrapolate. So it's unwise to do it for that reason. It would not be appropriate for that reason. So let's just check our answers. Extra 1 degrees. Okay, 2.81, hundreds of ice creams. 2.81 times 100, 281. I'm not sure I agree with that one. I think it's 281 extra ice creams, but let's just check. Yeah, it's definitely hundreds of ice creams, so I think the book's wrong in that case, and it's an extra 281 ice creams. Then the next one, outside the range of data extrapolation. Yes, we got that right. Right, hopefully that helped you. If it did, great. If you want to go over something else, then just ask. But what you should be doing when you're doing these exercises is looking at the answers in the back afterwards, checking them, and asking about anything you don't get wrong. The people who are more proactive are going to get more help and are going to do better. Okay, that's it for today.